Hello, everyone. So, you've built an awesome AI agent in Python. It works great on your machine, and we know it can solve a real problem that many people and companies need help with. That's great, but how do you turn that code into cash? Going from a working script sitting on our computer to a product that customers pay for involves more than just the coding. We need to handle clients, deployments, reliability, and, crucially, getting paid. In this video, we'll walk through a step-by-step example showing how to take a Python AI agent and turn it into a real, revenue-generating product. We will see how we can use tools like Stripe and GitHub, along with the deployment platform, to make this happen. We'll look at setting up outcome-based pricing, deploying our agent as an API, and managing customer billing. By the end of this video, we'll have our agent deployed as an API endpoint that the customer can trigger to run the agent. We'll also have a Stripe setup that is connected to our agent deployment so that we can bill the customer based on how many times they use the agent. Note that having a Stripe account is the main prerequisite to follow along. If you don't have one, the process is pretty straightforward from Stripe's website. So let's dive in. First up, let's briefly talk about pricing. For AI agents, outcome-based pricing can be effective. What does outcome-based pricing mean? It means our customers pay based on the actual results they get from our agent. For example, if we're selling an agent that can help with lead generation, we might charge per sales lead generated. Similarly, if we're selling an agent that can help with support, we might charge per support ticket resolved. And so on. The outcome-based pricing for AI agents is becoming increasingly popular because it aligns our success as the agent developers with our customers' success. Our customer pays when they get value, and we only earn when our agent delivers. This pricing model often makes the sales conversation easier because the return on investment is crystal clear. Plus, it shows our customers that we're confident in our agent's performance and committed to keeping it running smoothly. The main challenge is tracking that usage accurately, but we'll cover how to handle that in this video. Okay, to make this concrete, let's use an example throughout this video. Imagine we've built an AI agent that monitors a Google Sheet for new leads and automatically finds more information about those leads online, enriching the lead data. This is the end result of how the example agent works after we've built all the necessary pieces. The customer has a Google Sheet with a list of leads. When someone from the customer's team adds a new lead to the sheet, the agent is triggered. Behind the scenes, it searches the web for more information about the lead and then updates the Google Sheet with the new information. To make this flow work, we need to set up a few things under the hood. First, we need to set up a way to listen for new leads in the customer's Google Sheet. Second, we need to set up a way to trigger our agent via an API endpoint. Finally, we need to set up a way to bill the customer based on the usage of our agent. Listening for new leads in the customer's Google Sheet is straightforward. We can use Google Apps Script for this. From the Google Sheet, open the Apps Script editor from the Extensions menu. There we should add the logic to listen for new leads and trigger our agent via an API endpoint whenever a new lead is added to the sheet. Note that this Apps Script code does not hold the logic for the agent. It only listens for changes in the Google Sheet and triggers the agent via an API endpoint whenever a new lead is added to the sheet. So I'll not go into the Apps script in detail here, but the GitHub repo linked in the description has the full agent code as well as the Apps Script code in code.js file. The agent code itself is a straightforward Python script that uses the Gemini API to search the web for more information about the lead. The main agent logic is implemented in the lead enrichment agent function. This function takes the email of the new lead and performs a couple of searches sequentially to extract info about the lead. First, the agent will attempt to extract the LinkedIn URL and company name from the initial search results. Then if this info is incomplete, the agent will make two follow-up searches. First, to get the LinkedIn info, and a second one to get more info about the company. Finally, the agent defines the schema for structured output. This schema represents the structure of the columns of the Google spreadsheet that should be updated. The agent then makes one final prompt to the LLM to extract the structured data from the unstructured search results it has obtained so far. That's all as far as the core agent logic is concerned. Again, all this is included in the GitHub repo linked in the description. But notice that the agent logic is initiated by a process and callback function. This function is the one that receives the call from the Google Apps script, extract the email from the script, and pass it to the agent for processing. Then, when the agent finishes, we make a secure callback to the Google Apps script code that in turn updates the Google Sheet. But okay, all these technical details aside, let's say we've shown the agent to a potential customer, and they love it. They agree to pay us based on the number of leads our agent successfully enriches. How do we set this up technically? Step 1 involves setting up the billing infrastructure using Stripe. If you don't have a Stripe account, you'll need to create one first. Once this is done, we should go to the Stripe dashboard and create a new Stripe product. This product will represent the agent we're selling to the customer. From the Stripe dashboard, click on Products in the left sidebar. Then click Create Product. Give the product a name. In our case, let's call it Lead Enrichment Agent. Then we need to define the pricing of the product. Let's click into More Pricing Options. We should ensure Recurring Billing is selected. Then let's select Usage-Based Pricing and set it to Per Unit. Here we should set the price we agreed with the customer. Say $1 per enriched lead. Now, in order to track usage of our product, we need to add a so-called Stripe meter. A meter is a way to tell Stripe how many units of our product have been used by a specific customer. At the end of the month, Stripe will use this information to automatically bill each customer based on their usage of our product. So, let's add a new meter here. Let's give it a name, like Leads Enrichment Meter, and an event name that we will use later to report agent usage. Here I will just use the auto-generated event name and then click Create Meter. Once the meter is set up and selected, we can now finish creating the product by clicking Next to go back to the Add a Product form. Finally, click Add Product to complete the product creation. Next, you need to add our client as a customer in Stripe. Go to the Customer section, add the customer details, and that's it. The final step we need to do is to tell Stripe that this customer has subscribed to our product. To do this, we can open the customer's details and click Create Subscription. Select the product we just created, and that's it. We have now made all the necessary billing infrastructure setup from Stripe's side. Great! That's the basic Stripe setup done. You have a product, a way to meter usage, a customer, and a subscription linking them together. Now let's prepare our Python agent code for deployment as an API. To do that, we need a way for our agent to receive requests over the web. A really common way to do this in Python is using Flask. If you haven't used it, Flask is a lightweight web framework. You'll need to install it with pip install Flask. With Flask installed, the key change we need to make is to wrap our agent's core logic inside a Flask root. In a new file, let's import Flask and request from the Flask library and create a Flask instance. Let's then create an endpoint at /run that accepts post requests. Inside the function for this route, we'll get the incoming data using the incoming request object. We'll extract the necessary input, which is the lead's email in our example, and use that to call our agent's main function, the one that does the enrichment, and calls back to the Google Apps script. One more thing for deployment. We need a requirements.txt file. This tells the deployment platform which Python libraries our agent needs, like Flask, Requests, Gemini's SDK, etc. We can easily generate this by running pip freeze greater than requirements.txt in our project's virtual environment. Okay, code's ready. Make sure you commit your updated Python script with the Flask endpoint and the requirements.txt file to a GitHub repository. The deployment platform that we will use will pull the results directly from GitHub. Now, for the actual process of deploying the agent. We're going to use a platform called Itura for this. It's designed to make deploying AI agents and similar applications really easy. It handles the server setup, scaling, and integrates nicely with GitHub and Stripe. First, we'll need an Itura account. After signing up, we will connect our GitHub and Stripe accounts. Once this is done, we are now ready to create the deployment. Start the new agent wizard. In this wizard, we will need to select the GitHub repository and branch where our agent code lives. Itura will pull the code, install the dependencies from requirements.txt, and set up the API endpoint. The deployment process will take a couple of minutes to complete. When it's done, Itura will give you a unique URL for our agent ending in /run. This is the URL our customers will use to trigger our agent. But before starting to trigger the agent, there's a crucial step. We need to connect the Stripe customer and subscription we created earlier to this specific agent deployment. We can do this by going to the Customers view for our agent in the dashboard. Look up and add the Stripe customer. Then, select the specific Stripe subscription we want to associate with them for this agent. This way, the Itura platform will automatically report usage back to the correct Stripe meter whenever this customer triggers the agent. It also helps manage access. If the subscription is canceled in Stripe, Itura will automatically invalidate the API key, ensuring the agent is not being used without us being compensated. Speaking of API keys, we'll need to generate one specifically for this customer. We can do this from the API keys view, selecting the customer and creating a key. Also, don't forget environment variables. Our lead enrichment agent needs things like a callback URL, where to send results back to the Google Sheet, and an API key for the AI model. We can add these via the dashboard. A great feature here is that you can often associate environment variables, like the callback URL, with specific customers. This means we can use the same deployed agent code for multiple customers, each with their own configuration. Well, that's it. Everything is set up. Our customer can now trigger the agent by sending a post request to the /run URL we just created. Back in the Google Apps script code, we need to specify the URL of the agent endpoint. We also need to include the API key in the authorization bearer header of the request sent to our agent. Now the agent will be automatically triggered using the customer's API key and environment variables when a new lead is added to the Google Sheet. When Itura platform receives this request, it checks the API key, identifies the customer, injects their specific environment variables, and runs our agent code. And if our agent runs successfully and returns a success response, Itura platform will automatically send an event to Stripe, incrementing the leads enrichment meter we set up earlier by 1 unit or by a custom amount if our agent specifies it in the response. That's it. Stripe tracks the usage, and at the end of the billing cycle, it automatically bills the customer based on how many leads were successfully enriched. So let's recap. We saw how turning our Python AI agent into a product involves more than just code. We discussed outcome-based pricing using Stripe, setting up products and meters to track usage accurately. We prepared our agent for the web using Flask, creating an API endpoint. We deployed the agent easily using a platform like Itura, connecting it to GitHub for code updates, and Stripe for billing. And we saw how our customers can trigger the agent via its unique URL and API key, with usage automatically reported for billing. By setting things up this way, using tools like Stripe, Flask, and a deployment platform like Itura, we can handle the complexities of deployment, billing, and customer management, allowing us to focus on building great AI agents that solve real problems and generate revenue. Hope this gives you a clear path forward for monetizing your AI creations. Let me know in the comments what you're building. Thanks for watching.